Let's do a little division work in which we are dealing with remainders. The division that we did in the previous video, we had no remainders. Everything worked out evenly, and it was great. But life isn't like that, and oftentimes you're going to get remainders. Now, for this lesson, it's going to be acceptable to use the letter R to show the remainder, and I'll give you an example here in a minute. But when we get to fractions and decimals, I'm going to show you how to divide and make your leftover or your remainder into either a fraction or a decimal. Okay, let's get started. Let's start with 48 divided by 5. Now again, quick review, 48 is our dividend, and we want to know if we were to break this number into 5 groups, which is our divisor, how many items would be in each of the 5 groups? Okay. Now this one of course is going to have a little leftover, so that leftover wouldn't be added to the groups. Okay, it would just be kind of off to the side. Alright, so we're going to rewrite it. 48 divided by 5. And if while I'm doing these problems, if you want to pause the video and work on the problems and then start up the video again to check your work, that is perfectly fine with me. It's good practice. So 5 does not go into 4, but it does go into 48 9 times. 9 times 5 is 45. And then I'm going to subtract. 8 minus 5 is 3. And notice that there are no other digits after the 8, so I'm done. Okay, I'm not going to be bringing down a 0. This is the last digit. So this means this is my remaining piece, and I need to ask myself, does 5 go into 3? It does not. This is smaller than 5, so this 3 will be my remaining amount. Okay, so if I were to divide 48 into 5 groups, each group would get at least 9 pieces, but then off to the side there's going to be 3 leftovers. Let's do another one. Let's do one where we have a 2-digit divisor. So 418 divided by 25. And I'm going to rewrite it here. 418. Okay, so 25 doesn't go into 4, but it does go into 41 one time. 25. I'm going to subtract. I have to do some borrowing here, and then subtracting 6 and 1, and then I'm going to bring down that 8. Now I'm going to do a little guessing here. I know that there's 4 quarters in $1, and $1.50 would be 6 quarters, and this is close to that, so I'm going to say 6 times 25 is 150. Then I'll subtract, and I've got 18 left over. Because this is the last, this 8 is the last digit in our number, we're not going to bring down a 0. And 18 is less than 25, so then I'm going to have a remainder of 18. Okay, let's do one more. Let's do a 3-digit divisor. I'm going to rewrite it in the form that we're going to work with. We've got divided by 132. Okay, so I can see right away that 132 does go into 199 one whole time. I'm going to subtract. I've got 7 and then 6 here, and there's 0 there. I do need to bring down that 0. Now we got to do a little guess and check. Let's see. So here's a way you could cover the last digit in each number. So we've got 13. How many times does 13 go into 67? And you could do a little mental math here. You know, 13 plus 13 is 26. and then 13 more would be 39. If I doubled 39, that would put me over the 60s. So I'm thinking I don't want to do that. So maybe 4, well, 26 and 26 I think is 52. I mean, we could do a little guess and check. So let's just go ahead and guess 132 times 4, and then we'll see where we're at with that. There's really no one right way. You just kind of, if you have an idea, then you can go with it, and then if it doesn't get you anywhere, you got to make adjustments, and that's usually how it goes. So 4 times 2 is 8, 4 times 3 is 12, and then 4 times 1 is 4, plus 1 is 5. I'm thinking I might be able to add another 132 to this number, because if I were to add 1, that would put me in the 6, and the 3 would be a 5, and the 2 would bump that to a 10. So let's add one more 132, and that would mean that we're multiplying by 5. So we've got 10, 6, and 6. So we're close. We're only 10 away. So this number up here is going to be a 5, and then I'm going to rewrite that here, and our difference is 10, and 10 is clearly less than 132, and since we have no other digits here, we're not bringing down another 0, so we're done. We're going to say remainder 10. Okay? Now let me show you a way to check your work. If you don't have a calculator, we're going to multiply. We're going to use multiplication and addition to go backwards. So let's first look at this first problem. We had, let me get a different color here. We had, if we divided 48 by 5, we got 9 with a remainder 3. All right. So if we take our quotient, the not including the remainder, and we multiplied it to the divisor, so if we go 9 times 5, and then we're going to add the 3. Okay, so I know it looks, maybe if you want to rewrite it so it's makes more sense, where you have the 5 first and then the 9 plus 3, because this is together. If that makes sense, that's fine. So 5 times 9 is 45, plus 3 is 48. And that's what we had way over here when we first started, or right here. So this answer, 9 remainder 3, is correct, because I was able to go backwards and show that I went back to my starting point. Okay, let's do the same thing over here. We're going to have 25 times 16 plus 18. Now this one, I have to actually write out my math. I can't do this in my head. So I'm going to go over here where I have a little more room. 25 times 16, so that's going to be 30. That's going to be 12, 13, 14, 15. And then these are just going to be the numbers, because 1 times anything will be that number. Then I'm just going to add 0, 10, and that'd be 400. But now remember, I have to add that 18. So 418. And sure enough, that's what my starting number was. So if you're not sure, you can certainly go through your problem again, do the division again, or if you think you're right, take your answer and multiply it to the divisor, and then add whatever the remainder is, and that will definitely get you to your starting point. All right, let's see if I have anything else. Oh, I wanted to show you 2 other things, and these things are fairly easy, not as complicated as remainders. I just wanted to make special note of two things. When you're dividing a number by 1, what is that going to give you? So say if I have 10 and I'm going to divide that by 1, well, how many times does 1 go into 10? You should get 10, okay, because 1 goes into 1 one time. So I'll rewrite that here. I'll go 10 divided by 1. So 1 goes into once, and I'm subtract, and then I bring down the 0, and 1 goes into 0 times. So my answer is the same number that I started with in my dividend. And that's going to be true for any number that you divide by 1. I mean, we can take 3,429 divided by 1. What this is basically saying is that I'm going to take 3,429 things, like boxes, and then each group is going to have, I'm just going to have one group. So how many items are in that one group? Well, 3,429. Okay, so anyway, that's the one thing. The other thing is that you cannot divide by 0. So, for instance, 8 divided by 0, or it might look like this, 8 divided by 0, or maybe a fraction, okay, or something like this. This is considered to be undefined. You just can't divide something by nothing. There's no such thing as taking a number and then dividing it by nothing. So this would be considered undefined, and if you ever see anything like that, that would be your answer. You would just say undefined. I think the official reasoning, let me look in my textbook for the official definition. Division by 0 is undefined. Any expression with a division of 0 is undefined. We cannot divide by 0. So that's the only thing you really need to know. Cannot divide by 0. Okay, I think that wraps it up.